Hello and welcome to this lecture on complex integration. In this video, we are going to see about Taylor series. The first problem, they have given the function f of z, a log 1 plus z. We have to expand this logarithmic function in a Taylor series about the point z equal to 0. Let us first take this function and we want to know the general formula for Taylor series. It will be f of z equal to f of a plus f dash of a 1 factorial z minus a plus f double dash of a divided by 2 factorial z minus a whole square as goes on. Okay. So here they are asking us to find about the point z equal to 0 means we have to take let a equal to 0. So that means it will be of f of a will be f of 0, then f dash of 0 by 1 factorial z minus 0 means simply z plus f double dash of 0 by 2 factorial z square plus s triple dash of 0 by 3 factorial then z cube as shown. So this is what they have given. This is our f of z. So they have substituted as log 1 plus z. So we need to find f of z. To find f of z, we need f of 0. F of z will be log of 1 plus z. Then f of 0 will be log of 1. Log 1 will be 0. So this term will be 0. Next we need f dash of 0. That means we need f dash of z. So we need to find f of z. This is our f of z. Then we want to find the derivative with respect to z. So f of 0 will be 0 and f dash of z. So we know that f of z is log of 1 plus z. Then f dash of z will be, if I am taking derivative of this, it will be 1 by 1 plus z. Okay. Now just substitute the value. We need f dash of 0. So substitute the value z equal to 0. Then you will find 1. As same, we need f double dash of 0, f triple dash of 0, as so on. Again, here you can use u by v or else 1 plus z whole power minus 1. Then you can differentiate this function. Then you will get minus 1 by 1 plus z whole square. Okay. So this is very simple, I think so. If you find any difficulty, let us take the function 1 plus z whole power minus 1. If I want to find the derivative of this means it will be minus 1 into 1 plus z whole power minus 2. Then it becomes 1 plus z whole power minus 2. So that if I substitute z equal to 0, I will get minus 1. Similarly, f triple dash of z, I am getting triple dash of 0 will be 2. And for 4 dash, that means 4 times you have to find the derivative from f of z. If I substitute z equal to 0, then I will get minus 6. Then just substitute in the given formula. F of 0 will be, what's the, you are getting there, f of 0 becomes 0. Then f dash of 0. F dash of 0 will be 1. 1 minus 1. So here it becomes 1. So z term is there, simply z. And here it becomes minus 1. So minus 1, it will be of minus z square by 2. 2 factorial represents 2. Both are same. And triple dash of 0 will be 2. 2 divided by 2 into 3 factorial means 3 into 2 into 1. So 2 will get cancelled, only 3. Then as same it goes on. So at last this will be the Taylor series expansion f of z. The next problem, they ask us to find the Taylor series for the given function. So our f of z will be z by z plus 1 and z minus 3 with the condition mod z less than 1. So the next problem will be, we have to find a Taylor series expansion for the given function f of z. Okay, so let us split this f of z into partial fraction, a by z plus 1 and b by z plus 3. Then the next term will be z by z plus 1, then z minus 3 equal to a into z minus 3 plus b into z plus 1 divided by z plus 1 into z minus 3. Both the term will get cancelled. The remaining will be z a into z plus 3 z minus 3 plus b into z plus 1. If I choose z equal to 3, then if I substitute z equal to 3, then 3 equal to 0 and 4b. So the b value will be 3 by 4. If I choose z equal to minus 1, then what will happen? Minus 1 equal to a into minus 1 minus 3 become minus 4 plus 0. So a will be 1 by 4. So 1 by 4, 3 by 4. Okay, so now we can substitute the value of a and b. Then they have given the condition mod z should be less than 1. So we have to express this term in the form of Taylor series. So we have a general formula, 1 plus z whole power minus 1 can be written as 1 minus z plus z square minus z cube. It goes on. Sometimes 1 minus of minus 1 will be 1 plus z square plus z cube. It goes on. This works only when mod z is less than 1. So we can check, we have to check whether this value is suitable to use this formula. So now we can change this expression to 1 by 4 into 1 by 1 plus z. Okay, according to this. Then what happened? I'm just working for this alone. So 1 by 4, then 1 plus z whole power minus 1. So where mod z is less than 1 here. So we can apply this formula directly. Okay, so I'm changing that z plus 1 as 1 plus z. Now you just come for this problem. Z minus 3. What I said here, mod z should be less than 1. Okay, and while applying this two formulas, that should be 1 plus or 1 minus. But here it is of z minus 3. So we have to pick the value 3 outside. So it becomes z by 3 minus 1. But for to apply this formula, we need 1 plus or 1 minus as a first term. So we may take 1 minus outside. So 1 minus z by 3. So it becomes like this. Okay, you just see the denominator part, and then we can use that formula. 1 plus z whole power minus 1 will be, because this can be written as 1 plus z whole power minus 1. As same, this term can be written as 1 minus 1 by z by 3 whole power minus 1, this term alone. So we can apply the formulas directly. 1 minus z plus z square, it goes on. The same in the previous case. Here it is plus, means 1 plus 1 plus z whole power minus plus, sorry, 1 minus z whole power minus 1 means 1 plus z plus z square. It goes on this way. So in the place of z, here it is z minus 3. So z minus 3, it meeting the powers. Same in the place of z, here it is z, we are getting this expression. So 3 3 will get cancelled, and the remaining part we can take 1 by 4 common for both the terms, and 1 and minus 1 will get cancelled. Okay, and the next we can express this into z plus 3. If you raise the powers of n equal to 0, 1, 2, 3, you will get the value 1 by 1. So anyway, this plus 1 minus 1 will get cancelled on the next step. Here the value of n equal to 0. On the next step, we have changed n equal to 1. That means we have cancelled the first term. Then it will be of minus 1 whole power n, 1 by 3 whole power n in the general case. For both the terms will have a z power n as a general one. So we may take that z power n whole outside the given expression. And then at last, just I am simplifying it. So this will be the final answer.